So hello everyone, welcome you all to this video. So in my previous two videos, I have already discussed with module 1 and module 2 model paper solutions of this subject. Those who don't know the subject is intelligent systems and machine learning algorithms. So in this video, I'm going to discuss with module 3 model paper solutions, which is provided by the VTU. Okay. In this video, I'm going to discuss 5A, 5B, 6A, 6B in detail. Okay, with all the proper explanations. So my humble request to you guys is please like this video before you watch it. Okay, then try to listen this video till the end, because if you want to understand something, so be listening to it. Okay, otherwise you can just skip the video, and if you are only here for this video to access this PDF, it is available in the description. I will be providing it in short amount of time. You can go it and access it. Okay, I don't care if you do want to watch the video. Okay, yeah, I will be doing my job of doing this video. So yeah, let us continue now. Already I've discussed first four questions of model paper. The previous two videos, module 1 and 2. Those who want to watch it, you can watch it. It's available in the channel. Okay. So here the first question today I'm discussing it. How does the accuracy of a heuristic impact the performance of a search algorithm? Okay. The accuracy of the heuristic search significantly impacts the performance of a search algorithm, as it directly influences the efficiency and effectiveness of the search process. Okay. So how does it impact this algorithm? Is first point is should be noting down is efficiency. Efficiency is okay. The accuracy, efficiency, it is just one and the same. Efficiency means how good it is in searching step by step, and how quickly you would be getting the solutions. Okay, so this comes under efficiency. A more accurate heuristic leads to a fewer nodes being expanded. Okay, in order to be applying any problem in the search algorithms, efficiency matters when a few amount of nodes is used. Okay, if fewer amount of nodes is used, then you can say that it has a good efficiency. That problem has a good efficiency and you will be reaching the goal in an earliest manner. Okay, during the search, as I've told. For example, in A star's search algorithm, a heuristic that closely estimates the actual cost, that is actual path cost, helps prioritize the most promising nodes, thereby reducing the computational effort. Okay, by if you have the proper path cost, okay, which helps the upcoming nodes for your search algorithm, what it will be doing is we don't need to build any other nodes. Okay, so that's why it would be the nodes would be reduced in that computational effort. Okay, this comes under efficiency. Then we have optimality. The accuracy of the heuristic uh, approach determines whether the algorithm will find an optimal solution or not. For A star search, an admissible heuristic, one that never overestimates the cost, ensures the algorithm's optimality. Okay, this comes under optimality part. Next is branching factor. A better heuristic reduces the effective branching factor by narrowing the focus of the most relevant nodes, significantly improving the performance in problems with large state spaces. Okay, this comes under branching factor. Next is search depth. Okay, that is how many steps is required. Okay, that we checking the accuracy. In a particular search algorithm, the depth of the search, that is how many levels are required. With an accurate heuristic approach, the algorithm can reach the goal state faster by minimizing unnecessary exploration. Okay. For example, if you take the example of going from a location that is Arad to Bucharest, okay, in that, what are the unnecessary things you do by taking the long path? Okay. If you take the long path, that is unnecessary. If you travel a lot, it would be increasing the path cost, whereas the fuel consumption also would be more, which is unnecessary. Okay. If you have the shortcut path, better use that by avoiding the long path. Okay, that is the meaning of this sentence here. Then next is impact of poor heuristics. If the heuristic is inaccurate or misleading, the algorithm may expand many irrelevant nodes, leading to increased computational cost, that is increased path cost, and potentially failing to find the optimal solutions. Impact of poor heuristic, that is the heuristic approach also is very important in a particular search algorithm. Okay, so if you have a proper heuristic approach, then uh, the process of approaching towards the goal would be easier. Okay, so this was the accuracy part of the heuristic impact for the performance of a search algorithm. Okay, so this is the complete answer. Please note it down. Next question, come very important, guys. A fixed question from my side. I'm telling you, this will be coming for the exam for sure. Okay, what is the Whoopers world and how it is structured? Okay, structure part means this is the complete block part of Whoopers world. and what and all are the components are mentioned here. You can see here we have one start point and we have one compass which is located at the location 1 comma 3. Okay, 1 comma 3 represents the first row and third column. Okay, 1 comma 3, sorry, 1 comma 2, 3 here. Okay, yeah. The Wumpus world is a cave consisting of rooms connected by passageways. Okay. For each room, we have the particular passageways where we could be shifting from one box to other. Okay. Those are called as passageways. Structure of Wumpus world. So this is the structure of Wumpus world. Okay. You can see some of the components here is mentioned. One is stench, breeze, pit. Then we have gold, Woopus. So this is Woopus, the start point, and some other things. Okay. Yeah. What these complete whatever after ticked, right? It has a particular functions. Okay. So here also the problem is they would be giving you one initial position start and they would be mentioning one final position, that is at any box you should be. They would be telling you to reach that particular location. Okay. For that, but if you want to reach that particular location, what and all are the obstacles which you face and what would be its conclusions, that I'm going to discuss in this particular answer of the Wumpus word. Okay, so this is the block structure of Wumpus word. So note it down. First is the performance measure. Performance measure means 1,000 plus 1,000 for climbing out the cave with the gold. Okay, that is what are the results. Okay, plus 1,000 you can consider as some points or what. For example, from start point, if you are able to fetch the gold, you will be getting plus 1,000 points for climbing out the cave with the gold. Okay, that is with the gold. If you reach the final position, plus 1,000, minus 1,000 for failing into a pit or being eaten by the Wumpers. Okay, that is minus 1,000. That is in your particular location, in your particular path. If you fail the task of either you don't get the gold or uh, falling into a pit. That is, if you fall into any pit, okay, that would be considered as invalid or getting minus 1,000. Or the particular path, if you get eaten by the Wumpus, okay, Wumpus is a monster where if you by mistakenly reach that room, you would be killed or he would be eating you. Okay, for that minus 1,000. Minus 1 for each action taken and minus 10 for using up the arrow. Okay, the game ends either when the agent dies or when the agent climbs out of the cave. Okay, that is when the game would be ending either whether he would be dying or he would be failing the task or whether the agent is able to reach its final destination. Okay, so this is basically the performance measure. Next is environment. So this is completely a piece classification here. Okay, piece, you know that P stands for performance measure, environment, actuators, A, and sensors. Okay, hope you might be knowing this. Next we have environment. What is the environment here? You can see a 4 cross 4 grid, okay, of rooms. The agent always starts in the squared labeled 1 comma 1 comma 1. That is, this is the starting point of the agent, 1 comma 1. Okay, 1 1 you can see here. Facing to the right. Okay, that is facing to the right. The locations of the gold and the Wumpus world are chosen randomly. Okay, the location of the gold and Wumpus in that grid are chosen randomly. That is, it doesn't have a fixed location. It can be kept to any position random. Okay, with a uniform distribution from the squares other than the start square. In addition, each square other than the start can be a pit with probability point. This is the probability where each square other than the start can be a pit for this. Okay, yeah. The probability is 0.2 whether it is a pit or not. So this is the complete environment state. Actuators, the agent can move forward, turn left by 90 degree, turn right by 90 degree. The agent dies a miserable death if it enters a square containing a pit or live bumpus. Okay, so these are the actuator part. Okay, that is can move forward. If you want to move to this room, here he can move forward. If you want to move to this room, should be turning towards this room for 90 degrees. So this is an angle made 90 degree. And if we reach here, again, if you want to come back to this room, again you can turn, uh, 90 degree back, that you will be reaching this position again. Okay. So these are the turn right, turn left 90 degree part. Okay. If an agent tries to move forward and bumps into a wall, then the agent does not move. Okay. So this is the part. If the agent moves forward and bumps into a wall, then he can't move forward. Okay. The action grab can be used to pick up the gold if it is in the same square as the agent. Okay. The action shoot can be used to fire an arrow in a straight line in the direction that the agent is facing. The arrow continues until it either hits and hence kills the Wumpus or hits a wall. Okay. So these are comes under actuators part. Then the sensors part. The agent has 5 sensors, each of which gives a single bit of information. In the square containing the Wumpus and in the directly, not diagonally, the adjacent squares, the agent will perceive a stench. Okay. It's the stench here. The squares directly adjacent to a pit, the agent will perceive a breeze. Okay. The squares directly adjacent to a pit. Okay. That is the squares containing the Wumpus and in the directly adjacent squares, the agent will perceive a stench. That is the square containing Wumpus, just adjacent to that, we will be having a stench. Okay. As mentioned here. In the squares directly adjacent to a pit, the agent will perceive a breeze. Okay. That is in the squares which is directly adjacent to a pit. That is, for example, if you have a pit here, to adjacent to all the pits here, you will be having a breeze here. If you want, you can check it here. For this pit here, you see here, adjacent to this right side of this, we have a breeze. In this direction, we have a breeze. Adjacent to this also, we have a breeze. Okay. Similarly, here also see here, this is a pit. Adjacent to this, we have a breeze, breeze, breeze. Okay. This is a pit. Here we have a breeze. Also here we have. Okay. Adjacent to a pit, a breeze would be definitely there. Okay. That is the sentence here. It is mentioned. Okay. The squares adjacently to a pit would be having a breeze. In the square where the gold is, the agent will perceive a glitter. When an agent walks into a wall, it will perceive a bump. Okay. What is a bump? A bump is when an agent walks into a wall. That is called a bump. In the square where the gold is, the agent will perceive a glitter. Okay. That is in the square where the gold is, glitter is, you can see this dotted lines. Okay. That's the glitter part. Okay. When an agent walks into a wall, it perceives a bump. When the Wumpus is killed, it emits a woeful scream that can be perceived anywhere in the cave. That is, this is one more part. That is, when the Wumpus is killed, that is, for example, if you are moving and what are the chances of Wumpus getting killed here? Whether it falls into a pit or whether it attains a breeze and goes somewhere out of the cave, out of this box. Okay, those are the two possibilities where the Wumpus would be killed. If it is killed, it would be perceiving the scream in the complete cave, and you would be identifying that the Wumpus is killed, so that your path of reaching the destination would be slightly easier. Okay, so these are the sensors part. Okay, where actually the agent, where you would be finding the solution, would sense. Okay, this is the sensors part of this complete Wumpus world problem, and complete structure and the components in this Wumpus world and the 4x4 grid along with the agent and some of the important keys. I've tried to explain the complete Wumpus world problem. Okay, hope it is clear. Next question. What is the syntax of the propositional logic and how it is defined? Okay, we have some certain sets of syntaxes of propositional logic in this question 6a, and that I'm going to discuss now. The syntax of propositional logic defines the allowable sentences. The atomic sentences consists of a single proposition symbol. Each such symbol stands for a proposition that can be true or false. Okay, we use these symbols that start with an uppercase letter and may contain other letters or subscripts. For example, P, Q, R, W1, 3 and not. Okay, W1, 3 stands for the Wumpus 1, 3. Okay, the names are arbitrary but are often chosen to have some mnemonic value. We use W1, 3 to stand for the preposition that the Wumpus is in 1, 3. Okay, that is, if you want to mention Wumpus 1, 3, you can simply stand for a preposition. In short form, you can say W1, 3. Okay, remember that symbols such as W1, 3 are atomic, where W, 1 and 3 are not meaningful parts of the symbol. Okay, they are atomic, that is, you should be pronouncing it together. There are two proposition symbols with fixed meanings. Okay, true is the always true proposition and false is the always false proposition. Okay, next we have complex sentences are constructed from simpler sentences using parentheses and logical connectives. There are 5 connectives in common use under this propositional logic, which you should be knowing very carefully. First is this symbol here. Okay, check this symbol out. This is a not symbol. A sentence such as not of W1, 3 is called the negation of W1, 3. That is, if you want to inform anyone that Wumpus 1, 3, that is whether the Wumpus is there in that position or not, this is the particular symbol. If you want to mention, this says that the Wumpus is not there at that location. That is negation of W of 1 comma 3. A literal is either an atomic sentence, a positive literal, or a negative atomic sentence, a negative literal. Okay, so this is the literal. Next is this symbol here, okay, caps, or this is the and symbol. A sentence whose main connective is this symbol and, such as W1 comma 3 and P3 comma 1. Okay, W1 comma 3 and P3 is called a conjunction. It's part and the conjuncts. Okay, this looks like A for and, okay, and A for and, where it suggests that you want to connect any two possibilities at the same time. So we use this connectivity, that is and. Next is or. Or means you would be having two possibilities. You should be choosing any one of. Okay, that is I mentioned here. A sentence using this or, such as this or this, okay, is a disjunction. This is the conjunction part. This is the disjunction part of the disjunct of this possibility, which they mentioned it. Historically, this symbol comes from the Latin VEL, which means or. For the most people, it is easier to remember as V, as an upside down of this symbol and. Okay. Next is this symbol, that is implies. A sentence such as W1 comma 3 and P3 comma 1 implies to W2 comma 2 is called as implication. Okay, this is called as implication or conditional. Its premise or antecedent is that W1 comma 3 and P3 comma 1 and its conclusion or consequent, that is these two are, implies that if we apply this condition, we would be reaching this position in the lowest amount of time. Okay, this is the implies part. Implications are also known as rules if then statements. Okay, that is if we reach to this position, then we would be attaining this at this position in the fast amount of time. Okay, if then condition. Okay, keep it in mind, if then condition. Okay, this condition comes under implies. Next is this arrow, this symbol here, if and only. Okay, the sentence W1 comma 3 and W2 comma 2 is biconditional if and only if these two are similar to each other or any condition. Okay, it is left to you. Okay, what condition is applied. Okay, so this is the if and only if condition under the prepositional logic, and these are the connectives which I've tried to discuss. Okay, so note this down, very important. Next question: what are the semantics of propositional logics and how do they determine their meaning? Okay, what are the semantics? Okay, they have mentioned it here cleanly. Having specified the syntax of propositional logic, we now specify its semantics. The semantics define the rules for determining the truth of a sentence with respect to a particular model. In propositional logic, a model simply fixes the truth value, true or false, for every proposition symbol. For example, if the sentences in the knowledge base make use of the propositional symbols P1, 2, P2, 2, and P3, 1, then one possible model is M1 is P1, 2 is equal to false, P2, 2 is equal to false, and P3, 1 is equal to true. Okay, this is the semantic part where you will be representing the particular set of instances in a particular set. Okay, so that's called a semantic. Okay, the semantics for propositional logic must specify how to compute truth value of any sentence given a model. This is done recursively. All sentences are constructed from atomic sentences and the 5 connectives. Therefore, we need to specify how to compute the truth of atomic sentences. Okay, atomic sentences means unpredictable sentences, and how to compute them. The truth of sentences form which each of the 5 connectives atomic sentences are easy. Okay, that is true is true in every model and false is false in every model. Okay, that is one thing we should be keeping in mind. Okay, the truth value of every other preposition symbol must be specified directly in the model. Okay, for example, in model M1 given earlier, P1, 2 is false. Okay, so this is the truth fact. For complex sentences, we have 5 rules which hold for any subsentences P and Q in model. Here, if means if and only if. Okay, yeah. So let us see some of the set of instances or example. Minus P is true. IFF. IFF stands for if and only. So I'm going to say that if and only if. Minus P is true if and only if P is false in M. Okay. So this is the set of M. If P is false in M, then minus P is true. Because if P is false and minus P is true, then we can say that it is one and the same. Because we have minus P and P. Okay. P and Q is true if and only if both P and Q are true in M. Okay. If you want to pick this to be true, the condition is if both P and Q are true, then only P and Q would be true. Okay. P or Q. if P or Q is true, if either P or Q is true in M. Okay, this is just as the AND logic or logic. That is, in binary sequences, if we want to be the both value to be true, that is the value. If we want to be one, okay, if both P and Q are true. For example, zero for AND logic, what does it say? If we have 0, comma 0, the binary value, if you apply AND operation, we will be getting it as 0 itself. Okay, for 1, comma 1 also it is for 1, comma 1 it is 1. That is, both P and Q are true. Okay, if the value of P as well as Q, if it is 1, then the resultant will be 1. Rest for all the combinations it is 0. Okay, this is according to AND. Similarly for OR, okay, if either one of them is true. For example, if in 0 0 both are false, so it would be 0. Then 0 1 1 0 and 1 1, one of them is true, so that's why the resultant would be 1. Okay, so this is AND OR operation. P implies to Q. It is true unless P is true and Q is false. P is biconditional to Q is true if and only if P and Q are both true or both false. Okay, yeah. Biconditional means if both of them must be true or both of them must be false. Okay, so this is the biconditional state. The rules can also be expressed with truth tables that specify the truth value of a complex sentence for each possible assignment of truth values to its component. Okay, that is, they have mentioned it here. Okay, it's just as a binary table here, where you can simply write this as what to say 0 0 0 1 1 0 1 1, or they have written it as false false, false true, or 0 1 true false, or 1 0 true true, or 1. Okay, minus P means negation. That is negation of P. That is, if here we have false, the negation of P is true. Okay, then P and Q, the AND operation, then P or Q or operation. P implies to Q. Okay, that is it is true unless P is true and Q is false in it. Okay, that is, see here we have both false, so it is true, and we have P is false and Q is true, so that's why it is true. Then we have P true and Q false. Okay, then it is false. Okay, that's why then the condition they have mentioned it as unless P is true and Q is false. Okay, then only it is true. Okay, so that's why this is the table here, implies and biconditional. You can note it. Okay, so yeah, that's all for this video, guys. These are some of the semantics of propositional logic with some instances I've tried to explain it to you all. So this was the module 3 model paper solutions. Hope you like this video. If you like this video, you can like this video and give your honest opinions about this video, about how you like the explanation or not. Then stay tuned for the next video where I'm going to discuss with module 4 solutions of model paper. So exams are coming near. So please share this video to a huge number, guys. Thank you.